we are now going to look at the process of a muscle contraction. So an overview of this, effectively, is that the body detects the stimulus from the receptors. That could be senses, so eyes, taste, usually eyes, touch, potentially. And this stimulus is then sent down the central nervous system, so the brain and the spinal cord. And the brain consciously makes a decision on what to do. And that creates an impulse, and that is sent down the spinal cord to the motor unit. And that motor unit is then sends that impulse down into the muscle and eventually reach the sarcomere. Inside the sarcomere, there's actin and myosin, and then they bond, and using the sliding filament theory to create a response where a muscle is contracted. This is a very simple and quick explanation of it. So to put it in more detail, this is a basketball player in the gifted and talented group, and this student sees a basketball approaching him, and his brain wants to catch the ball. So his eyes detect the stimulus of the ball approaching him, and this then goes to his brain, which then he makes a decision on what to do, and that impulse is sent down his spinal cord, and then will go to his motor neurons, to his arms, as the arms will need to move to catch the ball. Now, as the impulse travels down the spinal cord, it will then transfer to a motor neuron, and this motor neuron has this myelin sheath that runs down the axon. And if the motor neuron is myelinated, that means the impulse can then jump over these myelin, and therefore reduces the time it takes for the impulse to travel down the motor neuron. And this process is called saltatory conduction. When it reaches the neuromuscular junction, the impulse will then travel into vesicles, and these vesicles contain a neurotransmitter known as ACH, and that ACH can then travel over from the presynaptical membrane across the synapse to the postsynaptical membrane. Once it's reached the postsynaptical membrane over the neuromuscular junction, the ACH is then triggers an impulse, and that impulse travels down T tubules through the muscle until it reaches the sarcoplasmic reticulum. Now, the sarcoplasmic reticulum is a store of calcium in the muscle, and when the impulse reaches that, calcium is released, and that then travels into the sarcomere. In the sarcomere, you have the actin and myosin. The actin is known as the thin filament, and the myosin is known as the thick filament. On actin, you have tropomyosin and tropin covering actin, and when the calcium comes down, the calcium binds with troponin, and that causes the troponin to change shape. The change in this shape then pulls the tropomyosin away, which then uncovers the actin binding site, which was previously covered by the tropomyosin. When the actin binding site is available, then the myosin filaments will then bind with the actin, as the myosin currently has ATP. When it binds, it forms a cross bridge, and that cross bridge is then pulled across, which is known as the power stroke. During the power stroke, these Z lines are pulled closer together, causing the muscle to contract. Once the power stroke is complete, then the ATP and the myosin is then produced to make ADP and an inorganic phosphate, and that then releases the bond between the myosin and the actin. The myosin then receives another ATP and then can then bond with another actin, causing another power stroke, causing the Z lines to become even closer together. And this process is repeated until the impulse is stopped from the brain, as then the sarcoplasmic reticulum will then stop producing calcium, and therefore the tropomyosin will then cover up the actin binding site again. Once the actin binding site is covered, that means the myosin then can't bond with the actin, and then the would return to its original shape. So the Z lines would then go back to its normal position. And this is then done, and the student from the gifted and talented group would then catch the basketball due to this. And this process since the sarcoplasmic reticulum releasing calcium to the Z lines coming closer together, that is known as the sliding filament theory. And finally, there are 4 types of muscle contraction. You have isometric contraction, and this is a contraction when the length of the muscle doesn't change, so it remains constant. And this would be key for a gymnast in the gifted and talented group, with, for example, the crucifix here, where the gymnast has to remain in this constant position to maintain their maximum points. So the muscles here creating abduction at the shoulder joint, they are in isometric contraction, as the length of them isn't changing during this position. Next is the isotonic contractions, and you have a concentric contraction and an eccentric contraction. Now, a isotonic contraction first is a contraction where the length of the muscle does change, and a concentric contraction, that is when the length of the muscle shortens. So the example here is in a bicep curl with the bicep brachii contracting, so shortening, to pull that dumbbell up against the resistance of gravity and the weight of the dumbbell. So the bicep is under strain and is shortening during this, during the upward phase. In eccentric contraction, the length of the muscle is lengthening, so getting longer while still under strain. So this would happen in the downward phase of a bicep curl, as the bicep brachii is still under strain, as it's trying to lower the dumbbell with a slower speed than it wants to. As, let's say, the dumbbell was 10 kilograms, the dumbbell would be providing a force of 10 g newtons downwards, and so the bicep brachii would then be trying to reduce the speed of that movement by providing resistance on the downward phase, which is why the bicep brachii is contracting, but the length of it is getting longer, so which is why it's called an eccentric contraction. Finally, there is the isokinetic contraction, and this is when, similar to the isotonic contractions, so the length of the muscle is changing, but this is happening at a constant speed or a constant rate. So the best example for this is a swimmer in the gifted and talented group performing breaststroke, as this is at a constant, the muscles are under constant resistance from the water, so is greatly performing isokinetic contractions. Isokinetic tractions, however, are very rare in sport, so this is the best example for it. And that concludes my presentation on the muscular system and how this will be applied to students in the gifted and talented group.